How did a simple pickup truck, originally built to haul tools and materials, evolve into a self-contained exploration base capable of carrying a full kitchen, bathroom, solar power system, and enough supplies to live for days or even weeks far from civilization? And what forces drove engineers to build some of the biggest truck campers ever created? 7 tons of steel, glass, and composite material, yet it all starts with a commercial truck frame designed for hauling concrete or towing a backhoe. The largest modern expedition campers ride on platforms like the Ford F-550, Ram 5500, Freightliner M2, and Mercedes-Benz Sprinter. But their numbers push far beyond anything seen in a typical RV lot. At the heart of these machines are engines built for industrial power. Ford's 6.7-liter Power Stroke V8 delivers 475 horsepower and a staggering 1,050 pound-feet of torque. The Ram 1500's 6.7-liter Cummins inline-6 is close behind at 420 horsepower and 1,200 pound-feet. Freightliner's M2, favored for even larger builds, packs a 9-liter Cummins with 380 horsepower and 1,050 pound-feet, enough to move a 13-ton load up a mountain pass without breaking a sweat. Gross vehicle weight ratings tell the real story. A typical Earthroamer XD-HD on a Ford F-750 carries a gross vehicle weight rating of 22,000 pounds. Krug Expedition's 6x6 platform, based on a heavily reinforced F-550, pushes the envelope to 30,000 pounds. The living module alone can weigh over 13,000 pounds before water, fuel, or gear is added. Even the more modest Sprinter-based builds routinely hit 11,000 pounds, double what most pickup trucks are rated to carry. These numbers aren't just for show. They set the boundaries for everything else. How much water you can haul, how many batteries you can mount, and how far you can go before the laws of physics or the highway patrol say enough. Each chassis on this list is more industrial machine than recreational vehicle, engineered to survive the kind of punishment that would destroy a typical RV in a matter of miles. The scale of these platforms demands a new way of thinking about mobile living. One rooted in the hard math of torque, mass, and payload, not just comfort or style. So what does it take to turn a work truck into a true off-grid base? The answer starts with the raw power and capacity of these chassis, but the real story unfolds in the systems that ride on top, the power, water, and climate technology that make autonomy possible. That's where the investigation leads next. Morning in an expedition truck begins with a turn of the tap. Water flows from a 150-gallon insulated tank pressurized by a 12-volt pump that barely sips power. The owner's daily log is precise. Water use tracked to the liter, battery charge checked at sunrise, solar input tallied by the hour. For a family of 4, that freshwater supply covers showers, cooking, and cleaning for more than a week. Gray water collects in a 70-gallon tank, while black water systems hold 30 to 50 gallons, depending on the build. Power management is a daily calculation. 30 kilowatt-hours of lithium iron phosphate batteries run everything from induction cooktops to a 12,000 BTU heat pump. Solar panels on the roof generate up to 2,500 watts in full sun, often recharging the battery bank by midday. If clouds linger or HVAC demand spikes, a 5-kilowatt diesel generator quietly fills the gap. The inverter, rated at 6 kilowatts, handles surges from air conditioning or microwaves without a hitch. Climate control is a constant negotiation. Keeping the interior at 68 degrees, whether in the desert or at altitude, means the heat pump draws about 1.2 kilowatts on average, spiking to 2.5 during rapid changes. Owners note that HVAC alone can use nearly a third of daily energy, making every amp hour count. With 30 kilowatt hours available, all systems, water, lights, fridge, HVAC, entertainment, can run for up to 6 days off-grid, longer with careful use and sun. Waste is engineered too. Composting toilets reduce black water. UV sterilizers and filters make creek water drinkable. The numbers: 150 gallons of water, 30 kilowatt-hours of battery, 2,500 watts of solar, 6 kilowatts of inverter, define how long the truck can roam before needing the outside world. Packing a full house onto a truck frame isn't just a matter of bolting on a box and calling it done. Every extra gallon of water, every lithium cell, every inch of insulation adds weight, sometimes thousands of pounds, right where it matters most. The moment a living module goes on, the chassis faces a new kind of stress. Axle loads spike. The center of gravity rises. Suspension, originally tuned for cargo or tools, now has to handle the constant sway of a moving apartment. A typical F550 starts with 13.8 inches of ground clearance at the front and 12.5 inches at the rear. Once tanks and batteries fill the underbody, that clearance can drop by 4 to 6 inches. Engineers have measured a post-build Freightliner M2 at just 9.3 inches after installing a 200-gallon water tank and a flat-pack battery module. That is not just a number, it is the difference between rolling over a desert wash and getting stuck on a rock ledge. To compensate, builders add taller tires, retuned shocks, and sometimes even airbag lift systems, but every adjustment brings trade-offs in ride quality, complexity, and cost. Frame reinforcement becomes non-negotiable. The original ladder frame, built for hauling gravel or steel, gets boxed in with cross members and steel gussets, adding up to 1 inch of thickness and several hundred pounds. This extra strength is vital. Without it, the twisting forces of off-road travel would quickly deform the frame, or worse, shear mounting points clean off. Yet every pound spent on steel is a pound taken from water, batteries, or personal gear. As one lead engineer puts it, you are always fighting gravity and leverage. The more you add below the floor, the lower your clearance. The more you put up high, the more you risk rollover. It is a constant balancing act. Every decision, from tank size to battery bank to insulation, even where to route plumbing, affects not just comfort, but whether the truck can survive a remote trail. Under the skin, these machines are a study in compromise, where autonomy and durability are bought inch by inch and pound by pound. Beneath the shell of a modern expedition truck lies a tightly organized web of systems, each designed for survival far from civilization. The chassis forms the backbone, steel rails braced and gusseted to handle the relentless stress of rough terrain. Along this frame, the drivetrain stretches from front to rear. A diesel engine, heavy-duty transmission, and transfer case distribute power to locking differentials at each axle. Instead of bulky axles or drive shafts hanging low, sculpted tanks and battery packs are tucked close to the frame, preserving ground clearance. A 200-gallon water tank, flattened to just 3 inches thick, fits between the rails, fully insulated to prevent freezing at altitude. Next to it, a flat battery module, armored in steel, delivers high-voltage power to the inverter and the heating, ventilation, and air conditioning system. On a thermal camera, the battery's heat signature glows when active, with heat sinks channeling warmth away from the cabin. Color-coded wiring harnesses run along the frame, linking sensors and controls to a compact power management hub. This hub, no bigger than a toolbox, juggles energy from rooftop solar, the alternator, and a generator, switching sources in milliseconds to balance demand. Above the floor, a 6-kilowatt inverter converts direct current to alternating current, powering appliances and climate control. The heating, ventilation, and air conditioning system, a closed-loop heat pump, circulates through foam-insulated walls rated at R30. In winter, it draws heat from engine coolant, and in summer, it vents excess warmth through the roof. Every system, water, power, climate, and waste, feeds data to a touchscreen panel at the entrance where tank levels and battery charge are tracked. This is not just a vehicle, but a rolling microgrid engineered for autonomy and endurance. The Revcon Trailblazer, built in the early 1990s on a Ford F-350 chassis, stands out as the first truck-based RV designed for true off-grid living. Its aircraft-grade aluminum shell cut weight and eliminated rot, while a raised suspension and tandem rear axles enabled it to tackle rough terrain. Those features set a template for everything that followed. According to historian Chris Revel, the Trailblazer was conceived to make weeks-long off-grid travel possible, not just comfortable. The real breakthroughs, though, came as material science and power electronics advanced. By the late 1990s, sandwich panel composites reduced wall weight by up to 40%, allowing larger living spaces without overloading the chassis. The arrival of lithium-ion batteries in 2008 tripled energy density compared to lead-acid, extending off-grid autonomy from 2 days to nearly 2 weeks. MPPT solar charge controllers, reaching 98% efficiency by 2018, shrank solar array size for the same output, freeing up space and weight for other essentials. Each leap, from lighter panels to denser batteries and smarter solar, unlocked new levels of capability, transforming the once rugged experiment into the modern expedition truck. As one historian puts it, the DNA of today's overland giants can be traced directly to these early innovations, where every material and system was chosen for a reason: to go farther, last longer, and live better off the grid. A price tag of $600,000 to over $1 million draws a sharp line between these extreme expedition trucks and anything found on a typical RV lot. That cost is not just for luxury finishes or brand cachet, it reflects the intense engineering, low-volume production, and regulatory hurdles that shape every build. EarthRoamer, for example, delivers fewer than 15 units a year, each tailored to owner specifications and built on a Ford F-550 or F-750 platform, reinforced for a 22,000-pound gross vehicle weight rating. Krug Expedition's 6x6 models, with their custom frames and portal axles, see even fewer deliveries, just 4 to 6 per year, driven by the complexity and labor required. Buyers face more than sticker shock. Rigs over 26,000 pounds often cross into commercial vehicle territory, triggering licensing requirements that vary by state. Some owners must secure a Class B license or even a commercial driver's license, depending on how the vehicle is registered. For those who can afford the price and navigate the rules, the motivation is autonomy. Weeks off-grid, unrestricted by campground limits, with systems designed for self-sufficiency and reliability in the most remote places on Earth. The exclusivity is built in, not just by price, but by the realities of production, regulation, and the demands of true expedition travel. Today, these machines blur the boundary between vehicle and habitat. Engineered autonomy for a world where infrastructure is never guaranteed. As off-grid living and remote work surge, their existence challenges us to rethink what mobility and self-reliance mean. The real question is, where does engineered independence take us next? Join the conversation below.